All right, day 13.
Hey guys, welcome
Looks like
back
we're
to
starting
100
off with
Days
some
of Code.
debugging.
Today, we're going to look at debugging, the
I
process
guess that's
of
my study
removing
day.
bugs from your code. If you managed to get to this point, you've probably written quite a bit of code already. And I will bet that you've probably made some mistakes, some typos, some errors, and some bugs.
Once or
So,
twice.
in this lesson, I want to talk about some techniques and tips for how to find bugs and how to get rid of them from your code. Now, the first documented bug was actually found by this lady, Grace Hopper. She was probably one of the first programmers and one of the pioneers of the job that we're undertaking right now. Now, in her notes, you'll find a moth that's been taped to the notebook. And this was found in a relay that was preventing her code from running properly.
At
And this was
Harvard,
pretty much
actually.
the first actual case of a bug that's been found in a computer. Even though we're not dealing with moths these days anymore, we're
Pretty sure
still
it was
going
Harvard.
to end up finding bits of things in our code that prevent the code from doing the things that we want it to. The important thing to remember is don't feel down when you've created a bug because everyone gets bugs. And when I say gets bugs, I mean we create them, right? So once you've gotten over this, next I want to talk about some of the tips and techniques that you should follow on how to quickly be able to identify and remove these bugs. So the first step is to describe the problem. If the problem is messy and it's not well understood in your head, then it's almost impossible to debug it. So untangle the problem and try to make sense of what's going on. Now, in this block of code, we're going to practice describing the problem to help us solve this debugging problem. Now, if you take a look at this function, you can see that at some point in the function, we're supposed to print this line out into the console. But if we go ahead and hit run, you can see that nothing gets printed. So what's going on here? I want you to take a look at this function and describe the actual problem. What is the for loop doing? When is the function meant to print you got it? What assumptions are you making about the value of I? So pause the video, read the function, and have a go at describing the problem.
Alright, I do have this pulled up in PyCharm, so might as well. Alright, what is the for loop doing? Well, it is going through the range of 1 to 20. So each number from 1 to 19 because 20 is the exclusive ceiling. Um, when is the function meant to print and when I equals 20? What are your assumptions about the value of I? It'll be 1 through 19, so it'll never equal 20, and so this will never print, just like she said.
All right, so what we've got here is we've got a function that loops through all the numbers between 1 and 20, and then once that number reaches 20, it's supposed to print you got it. But the problem is that when I reaches 20, it doesn't print this line into the console. So now that we've described the problem and we understand what's going on, let's see if we can solve it. If we think about this problem, when I reaches 20, it doesn't print out this line. There's an assumption in there, right? The assumption is that I will definitely reach 20. But if you think back to how the range function works, the stop or the upper bound is actually omitted. So when you write range 4, it actually produces a number from 0 up to 3. And in our case, when we write 120, it actually goes from 1 all the way up to 19, but not including 20. The problem here is that I actually never reaches 20. So this assumption is completely false. Pause the video and see if you can fix the code so that this line actually gets printed.
I mean, we could put it
Alright,
to
so all we
equals
need to do
19.
is change this to 21 instead of 20. And now
Do
when
that
we
too.
hit run, you can see it actually works and we managed to debug this problem. Always, when you come across a problem in your code, try to describe it so that you really understand what the issue is, and then test your assumptions and see which of those assumptions is actually false. Now, the next step is to think about reproducing the bug that you've encountered. Because when you encounter it once, but you don't encounter it the next time, that becomes a really difficult bug to fix. In this section, we're going to try and reproduce the bug. So when we run the code, sometimes it will work and it will print out one of the dice images from this list, but occasionally you will get an error. These types of bugs are really difficult because you might test your code only once or twice and it looks all fine, it works, but then occasionally you get an error. And the important thing is to reproduce that error. When does that error actually happen? And based on that knowledge, we can fix our code. Try to reproduce the bug yourself and try to notice when it happens and see if you can change the code so that it always produces this error.
Okay. Always produces the occasional error. List index out of range. So it looks like because so rand int has an inclusive ceiling, so it'll be all numbers between 1 and 6, including 6. Whereas this list only goes 0, 1, 2, 3, 5. Uh, so what we can do is, instead of that, just call it 6. Now there we are, always getting that. Whether or not that's what she's going to do as well, we will see.
We've got a list of dice images, which are just emojis, and we've also got this random number, dice number, between 1 and 6. Now, when we try to pick out of our list, occasionally we get an error. Now, we have to notice when the error occurs, and to reproduce the bug, we have to figure out which of these numbers is actually causing the problem. So we know that this is a random number between 1 and 6, and if we check the documentation, it tells us that randint works a little bit differently from range. It will return a random integer in the range of A and B, including both endpoints. So in our case, both 1 and 6 could be generated, and it could be any number. So if that was equal to 1, well, does it generate an error? No, it just picks out this particular item. But what if it was 2 or 3 or 4? Or what if we tested 6? Well, now every time we hit run, you can see we get an error. And now that we've got our error to show up consistently, it's a lot easier to debug because we know that the index error, list index out of range, happens when this dice number is 6. So when we go back to our previous code, well, we can't use 6 in this list because lists start counting from 0. So to get this dice 1, we need dice num to be 0. And then this is 1, 2, 3, 4, 5, and 6 is somewhere out here and it doesn't exist. Now go ahead and fix this code so that all the dice images are represented and we never see this error again.
So instead we will do rand and 0, 5. Never again.
Alright, so that is as simple as shifting down these numbers. So instead of making a random number between 1 and 6, we actually want a random number between 0 and 5. And now, no matter how many times we run our code, we're never going to get that error show up again. Very often, I've asked you, in the quizzes especially, to play computer. And the reason is because this skill of pretending to be a computer, reading through your code, and imagining what you're going to do each time is really, really useful, especially when you're debugging. Take a look at this code. It takes an input in the form of an integer, and it asks the user for their year of birth. And then it uses an if statement to check if they were born between 1980 and 1994, in which case they're classified as a millennial. But if they were born later than 1994, then they're classified as a Gen Z. So depending on which country you're from, there's different classifications for your particular generation. This is just the typical words that you hear on the internet. You're a millennial, you're a Gen Z, you're a baby boomer, and this comes from a lot of the history of the US. But nonetheless, I want you to run the code and I want you to see what happens when I put in 1994. Absolutely nothing. So we have our bug right there. Run through the code line by line and evaluate each statement and follow the logic and check what it will evaluate to. So I want you to play computer and figure out what is the problem and then go ahead and fix the bug. Pause the video now.
Alright, so because I actually... this one has me mad, because I'm born in 1994, and I am a millennial, so I know that it is less than or equal to 1994 because 1995, then you are Gen Z, which means 1995 is greater than 1994, you are a Gen Z. Simple enough.
All right, so let's pretend that we got 1994 as the input. So now I'm the computer and I know that this year is equal to 1994. Now, with this year being equal to 1994, I go into this if statement. So is 1994 greater than 1980? Yes, it is. So this actually becomes true. Now I have to check the second condition, and it also has to be true for this if block to be triggered. So is 1994 less than 1994? No, it's not. It's actually less than equal to 1994, or it's equal to 1994. So in this case, this condition becomes false. And we know that if we try to combine a true and a false, then it actually just becomes a false. So this gets skipped. Now next, we look at the next statement, right? If 1994 is greater than 1994, well, that's also not true. It could be greater or equal to, or it could just be equal to. So this condition is also false. So that means it's also going to skip this next line, and there's no more lines of code left, which is why the computer doesn't print anything. So let's restore our code to before we started playing computer, and we can identify that this problem occurs because there is no bucket that actually catches the 1994. We could simply fix this code by changing one of these conditions to be greater than or equal to either here or here. And that means that the year 1994 is not skipped over in our conditions. And when we hit run, it'll actually tell us that we are in fact a Gen Z. Now, the next step and the next tip is pretty obvious. When the editor is giving you an error or when the console is giving you an error, fix the errors before you continue. Now, this is a little bit easier when you're dealing with errors in the editor because it'll actually highlight to you the line that's broken. So here we've got a print statement, and when we hover over it, it tells us that it expected an indented block. So that should be a good enough clue to tell us what's actually wrong. So if we go ahead and indent this block, then that error goes away. But that's not the only error, no. When you run this code, you still get another error. So let's say that I am a 12-year-old girl. We get another error. And this error does not show up when we write the code, but it only shows up depending on what input we gave to this age variable. So now we have a different type of error. We have an error that's in the console. How do we solve this error? Well, the easiest way is just to select the parts of the error that's not specific to your code, such as this part where it says 12 or our actual line of code. So if we go ahead and copy this part of our error and go into Google and paste it into the search box, and then we add our Python programming language, we should be able to figure out what is going on. So here is the exact same error that we have, and we have 17 answers explaining to us what could go wrong. And in this case, it says the error message means that the string provided to this int conversion could not be passed into an integer. So it couldn't be turned into an integer. And of course, the computer doesn't know how to turn 12 into the actual number 12, because you might have used even a different language. You might have used French, or you might have used German, right? So this doesn't actually work. And that should give us enough of a hint to know exactly what is going on. Now, of course, the easiest way is we could just tell the user to not do that, tell them to actually type numbers, and then we don't end up with that problem. But inevitably, things might happen down the line, people might do something that is unexpected. So given that we have this weakness in our code, how can we actually fix our code to make it more durable? Well, one thing that I want to introduce you to for the first time here is the try except block. So we can catch an exception using Python code. So the way that it works is we know that the potential error is something called a value error. So we can catch that error so that it doesn't crash our code and provide an alternative pathway for our code to go down. So the way that it works is we take the line of potentially dangerous code, which is this line, where we convert a string that the user types in into an integer. And we've seen that that is what's causing this error here. So we take this line of code and we trap it inside a try block. So just the keyword try plus a colon, and then we indent this block of code to put it inside. So now we've got a try block. The next part is we need to add the except keyword and then add in the exception that we want to catch. So in this case, it's a value error that we're getting, and so that is what we're going to be catching. So now inside this except block, what we can do is we can say, well, what should happen if we end up with this error? So where the user types in something that we actually can't convert into an integer. Well, let's first print something to tell them this is what's going on. For example, you have typed in an invalid number. Please try again with a numerical response such as 15. So now we're giving them a little bit of feedback, telling the user what's going on, and then we can just simply copy and paste this code here so that it runs again and we give them another chance. So now let's run this code again and try with our previous offending code. And now you can see that we get our print statement giving us clear feedback, what's wrong, and then it asks us, how old are you? And now we can type in a number and continue our program as normal. So it continues running instead of stopping our program and crashing it. But remember that solving the errors don't always
You
solve
put
all of
an
your
F in
bugs.
front of the string,
Like
silly.
this. In this case, there are no errors with my code whatsoever. It's just not doing what I want it to do. And these are the most frustrating bugs to debug because nobody is helping you here. There's no errors that you can Google. There's no underlines that you can check. You actually have to rely on your skills as a programmer to fix this. So pause the video and see if you can fix the code so that instead of displaying the name of the variable, we actually get the value of the variable. Pause the video now. Now we, of course, know that this needs to be an F string in order to insert that variable into this position in the curly braces. But if you didn't, then this would be a lot harder to debug. Experience comes in really handy with debugging, and the more bugs that you solve, the better you get at it. So go onto the internet, try to help people on Stack Overflow, go on to the Discord channel for the course, try to solve other people's bugs, and you will find yourself getting stronger and better day by day. Now, the next tip has been the thing that you've probably been screaming out for. Why don't we use print? And indeed, you are correct. Print is basically your best friend. Now, as developers, I know we don't have a lot of friends, but at least we can rely on print to be our trusty friend. Do you have heartbreak? Use print. Now, print probably can't help you with your relationship issues or family issues, but it can help you debug your code. And now I'm sure you're pretty much dying to use print to solve these debugging issues. Why, Angela? Why haven't you been using it before? Well, I've been saving it for this perfect moment. So here we've got a very simple program that figures out the number of words in a book. Words starts out at 0, and we have to input the number of pages in our book and the number of words in our book. And then we multiply the pages by the words to calculate the total number of words in the book, and then we print it out. But if we have a go, you can see that, let's say we have 45 pages making a booklet, and we have 250 words per page, and we get 0. So the output that's supposed to tell us the total number of words in the book ends up being 0. So what's going on here? How can we debug this? Let's go ahead and use print. Take a look at the code and see if you can use print as your friend to help you solve the issue. Pause the video now and give that a go.
Okay. Okay, there we are. Right. Words per page equals 0. Come on, man. Alright, number of pages 50, 250, 0. Alright, so we are seeing that it is printing 0 forward per page, and so, 50 times 0 is going to come out to 0. Uh, but why? Why is it not? Oh, there we are. Because when it's double equals, it's not assigning the value, it is checking the value.
What are our assumptions? Well, we're actually getting the number of pages and the number of words correct so that we can calculate this. Why don't we add some print statements before the final one? Let's print what's the actual value of some of our variables that we're getting from the user. For example, I could say the pages equals, and then insert the pages variable in here in an F string. And I can also print my other variable in an F string, which is the word per page variable. And this is equal to, let's insert that variable as well. And
It's annoying that
now
she
when I run my code, I've got
named
my
it
print
word per
statements
page.
going and I can test it out. So we've still got 45 pages and then 250 words per page. And now you can see that my variables are logged. So this one, this pages variable, does equal 45, so it captured my data correctly. But the word per page equals 0, which is not what I entered at all. I entered 250, so I was expecting this to be 250. So now, using print, my best friend, I've managed to narrow down the problem. It's something to do with this variable. So let's take a look at what's going on here. Well, I've spotted the problem. Have you? Pause the video and see if you can fix this code so the final total number of words actually gets printed when you run the code. Pause the video now.
If I would have hovered over that line and
All
just
right,
read,
we've
it probably
narrowed
would have told
down
me
to
to.
this one line of code that's probably broken. And if you look closely, you'll see that instead of a single equal sign, which means assignment, this variable should be equal to this value, we had two equal signs. This means, does this variable equal this value? And this actually gets evaluated and becomes either true or false. Now, in this case, it's actually false. Words per page starts out being equal to 0, and then it becomes equal to 250. So if this line of code is false, then that's just left as it is. It doesn't actually affect anything. And this total words is still using 0, which is why it's printing out 0. So now that we've identified the issue, all we have to do to fix it is that. And if we run our code again, you can see it works exactly as it should do. And we can in fact delete this line to get rid of any other warnings.
Using a debugger.
Now, before you start getting really committed to print and start making friendship bracelets for this print statements, there's another tool that I really want to talk about. And it's a tool that's bigger, it's fancier, it's more complex. So
big projects,
what is it?
It would
It's a
definitely
debugger. And we've already seen debuggers a little bit.
Inefficient.
So I've already shown you pythontutor.com, and you've also seen us use the debugger in the Thonny editor right here. Now, in the starting code, we have a function called mutate that takes a list as the input and then prints another list at the end. So what happens is we start out with this B list being an empty list, and we have a new item that starts out being 0. Then we loop through each of the items in the A list that comes in through the input, and we multiply it by 2 and turn that into the new item. And then we modify the new item even further by adding to it a random number between 1 and 3. Finally, we use a function called add in our maths module, which we created right here, and it does the simple thing that you created before, which is just to add one number to another. So we add the new item that we've got up to now to the item that we're currently looping through, and finally we add it all to our B list, and hopefully we are able to modify the A list with this step-by-step approach to end up with a new list where each of the numbers is modified according to our rules. Now, unfortunately, at the moment, it does not do what we expect it to do. It just prints out a single number in a list. So in order to debug and figure out what is wrong with our code to be able to fix it, we're going to cover how to use the debugger in PyCharm. Now, debuggers are pretty similar in most of these intelligent development environments, such as PyCharm. So I'm going to use this opportunity to show you a lot of things that will be reusable even if later on down the line you choose to use a different code editor. Now, what we do first is we can define what's called a breakpoint. So a breakpoint can be created in the gutter of our code, and you might have done it accidentally before. So when I hover over these line numbers in the gutter, you can see this red dot appears. And if I decide to go onto line 9 and click on that red dot, I've now created a breakpoint. And you can see that breaking line is now highlighted. So now I'm going to go into the debug run mode by clicking on this little bug here. And it's going to run my current file, and it's going to take into account the fact that now I have a defined breakpoint. So what does a breakpoint do? Well, it basically puts a break on the code.
This looks like it'll take a little bit of getting used to, a little learning curve, but it's going to be so helpful.
At that particular line. So here is where I'm setting the new item from 0 to a new value, which is the value of the item multiplied by 2. Now you'll see a couple of things show up already in line in our code, which is kind of helpful. It's showing us at this point where the code is at, where we've stopped the code on line 9. The current value of a list is this big list, which we inputted right here. So this is the input for this function, and that's showing up right there. And then it's showing us B list is still an empty list, new item is 0, and item, which is the first item in the A list that we're looping through right here, is equal to 1. So now what we can do is use the first of the step buttons in the debug console. So if I click on this one, which is called step over, what it's going to do is it's going to execute my code line by line, stopping at the very next line. So now that we've executed this line, which we've broken, it's now happened, and we can see that what's updated is the new item is no longer equal to 0, but it's now equal to 2, because we took the item, which is 1, multiplied it by 2, and then set it equal to new item. So new item is now equal to 2 instead of 0. So we can continue stepping over to the next line. And remember that the highlighted line is the one that's going to be executed next, and the line above it is the one that just got executed. So right now we can see that this line 10 has just been executed, and we've generated a random integer between 1 and 3. And we've added that number to our new item. So now our new item is equal to 5. So while we're here, we can do something else. We can look at another one of these buttons. So if I go ahead and rerun my debugger, and I use, instead of the step over button, I click on the step into button. So it's going to continue executing each line as it goes, line by line. But when it encounters a line such as line 10, where we're using another module, so code in another file, such as this randint function from the random module, when I click step into, it's going to go into the definition of that function, the randint function, in the random module from random.py, which is built into Python. And it's going to show you how that function works. So in fact, randint actually uses another function called randrange. And if I continue stepping into it, it will go and find this function randrange and show me how that function works. Now, once you're done exploring this, which can be really helpful because your code relies on code that's been written by other people, and if you want to know how they've defined it, how they've created randrange, then you can read through their code, and sometimes it can provide.
Like, I know if I spent more than 2 seconds looking at this, I would actually probably be able to make some heads or tails. But once I start seeing underscores like before and after, like these function calls and variable names, and then you got self, and it's like it just feels a little overwhelming without. I still need my handheld, okay?
Helpful hints for us to figure out what is wrong with our code. Now, you don't want to continue stepping through other people's code, so when you want to exit, you click on this button, which is step out, and we can continue stepping out until we get back to the code that we want to examine. So this can be really helpful where we're stepping through the functions, but more often than not, we don't actually want to step into the library functions such as random because they work the way they do and we can't really modify it. So we probably haven't made a mistake there. And what we want to do sometimes though is we want to be able to step into code that is in other files, but only the code that is written by us. And we want to ignore these library functions written by the Python team. So how can we do that? Well, let's repeat from the beginning. So this button restarts our debug run and again pauses on our breakpoint. Instead of using this step into button, we're going to use the step into my code button, which does exactly the same thing as step into, going line by line, but it ignores the library functions. For example, that random function right there. It doesn't take you over to the random.py file. But now, if I click into step into this current line 11, then it takes me into this file that I created, math.py, where I created this function called add. And it shows me that right now I'm trying to add 4 to 2, which was passed over from the previous function call. And if I step out of that add function in the math module, I can go back to examine my file. So this button can be more useful when we have multi-file projects and we're trying to examine the cause and the relationship of what could be going wrong in our code. Because very often, as our code gets more and more complex, there's more and more relations that start happening. And we're sometimes using code that's been defined elsewhere, and chasing it around can be quite difficult. So those are some of the most important features of the debugger. And I want you to take a look also down here. We've got 2 tabs here, the threads and variables and the console. So the threads and variables can be really helpful, showing us the values of the variables that we've got going on. So for example, just as they've shown up here as these comments, you can also see them in the list right here. What's the current value of new item at this particular time point? What is the current value of B-list at this particular time point? And as you can see that as I continue stepping through my code line by line, these values, they update as they get changed in the code. So we can actually trace what's happening to each of our variables in their intermediate stages. And especially for something like a for loop where everything is pretty much hidden, we don't know what's going on while it's looping, this can be really, really helpful to help us figure out what's wrong with our code. So the other tab here is the console, and you can see that it shows what gets printed during the run of the code. So for example, if I was to get rid of this breakpoint, so I can either disable it by clicking it once and it goes into this darker color, or I can keep it there and simply say mute breakpoints. Now, if we continue running through our code and stepping it through, you'll see that eventually it ends the loop and goes to the print, and we can see that print happening in the console. So we get our console even when we're running in debug mode as well. So that's pretty much all there is to it, to the major features of a debugger. The most useful thing, I think, is just simply being able to see these values show up as you go through the code, stepping through each of the lines. So now it's your turn to use what you've learned about the PyCharm debugger and figure out what is wrong with our code. Why is it not printing out an entire list with 1, 2, 3, 4, 5, 6 items, and instead why is it only modifying and printing out the first item in the list? So pause the video and complete this challenge.
Alright, well, she's only got 2 minutes of explanation, so this cannot be but so hard. Alright. I'm supposed to use the debugger, so I'm going to try and do that instead of trying to walk through it step by step by step. Sure, allow access. Okay. So we have our A list that has been called by mutate. Our inner function list is empty and new item is 0. Step into will enter into other modules that your code references. We definitely don't need to really, like, we know what this does. We know what this does. So we definitely I don't think need to step into right now. But we can definitely step over, right? So line by line, for each item in a list, item 1, that is the first number here. So new item equals 1 times 2. That's reflected right there. New item plus equals a random integer, so looks like it was 2 plus 2. So we're going to add 4 plus 1. So 5. Alright, well is it really just as simple as this needs to be indented? Simple as that. because with that back there, it was just incrementing on that one single value without actually appending it. But now we have it appending, and then it'll start fresh. I believe. Let's make sure. All right, I need to. I was about to say there needs to be a. All right, so we see that item is 1. That's correct. Yeah, there's no way to go back, huh? All right, so new item equals 0 here. 1 times 2 is 2. Okay, so plus equals a random integer, comes out to 3. Then we take 3 plus 1 is 4. And then we append that to blist. So now we should see that blist is 4. But new item is still staying. And what I think we want now, it's just a matter of is new item supposed to be 0 for every iteration? I'm inclined to think yes. Or are we just... I think I'm just going to move this. Stop that. And that way, every time we start new, we'll start at 0, and then that's what I think it wants. Whether I'm right or wrong, I don't know. But that looks... There's... It's not throwing any errors. And it's
All right,
printing
so
more
with
than
our breakpoint
one
in its
single
current position, let's do another
listing
debug run.
does, so.
And we are going to watch the value of the B list and see if it's changing the way we expect it to. So as I step over each of these lines and we're looping through the list, one thing you'll notice is that the value of B list is not changing at all. So at which point does it actually get populated with these new items? Well, it's on line 12.
Okay, so it's
let's
only getting
disable
appended
this and put our
all
breakpoint
the
here
items
instead.
have been ran through.
Let's go ahead and resume our program until it runs to this point. And we can see that B list is still empty, and all that's happening is we're appending new item. So new item is currently equal to 42, as we can see here. And if I step over this line to execute it, you can see that 42 gets added to the B list. And then if I step over once more, you'll see that print statement execute, and that 42 gets printed. And then that's the end of our code. So What's happening is that these new items are not being added to the B list as they're created. So the only thing we need to do is just to add an indent. And so often my Python code fails because of an indent or because of something silly like that. But with the debugger, it makes it a lot easier to figure out what is the problem.
Yeah.
So if we do another debug run and you watch how this B list changes now, every time we loop through B list, once we get to the end of it, that new item gets added to the B list. And you can see it adding a new item each time the loop runs. And that is what we expect to happen. So a debugger can be really useful. It's almost like you've put a print statement on all the variables in your code, and you can isolate a particular time point to see what each of the values are. And as we become even more experienced, we're going to be using the debugger more and more. Now, I've got some final tips for debugging, and these are not so much techniques, but they're just really, really important tips from somebody who's done quite a lot of coding and created a massive amount of bugs in my lifetime. So tip number 7 is take a break. It's really, really important when you're just staring at the code and you keep looking at it, it's not going to tell you the solution. Just have a cup of tea or have a nap or just go to sleep and try to tackle it tomorrow. You will be surprised just how much easier things are when your brain's had some downtime and then you come back to it. Everything seems so much more obvious. And if you really, really get stuck and you just can't see it, ask a friend, not your friend print, but your actual friend, a real human, preferably a developer, but they don't have to be. It could be somebody who's taking the course with you. You could go onto Discord and find other students to help you. Because after all, you're all just leveling up your own programming skills, right? The really good thing about asking a friend to look through your code is they won't make the same assumptions that you've made. So they have some fresh eyes that they can look at the code with, and it might be incredibly obvious what's actually happening. And it's really not embarrassing at all. If somebody managed to help you with your code, you can offer to help them the next time when they get stuck. And for the person who's helping you, they're also just working out their programming muscles, right? Now, the next tip is to run often. No, you don't have to go exercising to be a good programmer. But what I mean is run your code often.
Yeah.
Don't wait until you've written loads and loads of code to hit run
Just
and
been
then
typing
find
for
out you've
half
got
an
loads
hour
of snags
and
and
then,
loads of bugs. But run it after every little execution. Once you feel like you've changed the program ever so slightly, run it. Confirm that it's actually doing what you want it to do. Because if you leave it all to the end, then you end up with a pile of bugs and you don't know where to start. Now, if you do end up in that situation and you can see multiple bugs at the same time, try to tackle them one at a time instead of trying to do bits and bobs of each. It'll really, really help. And the final tip is, of course, Stack Overflow. I've saved this to last because you really don't want to take every single small bug of yours to Stack Overflow. That's not what it's designed for. Instead, it's really designed as a way of asking other developers when you think that you've come across a bug or an issue that should be unique. Now, if you think that your issue isn't unique and other people should have encountered this, then just search Stack Overflow. If you really think that nobody in the world has had this issue that you're having right now, then that's the moment to ask the Oracle, Stack Overflow. I've worked in a lot of companies where everybody just goes to the pub when Stack Overflow is down because there's just no point. As programmers, we use it and we search it so much that it's become a really vital tool in the tool belt. But you only want to ask a question when you're pretty sure that you've exhausted all other avenues of debugging and you've searched all of Stack Overflow and you finally end up with something very strange and very weird that you want others to help you figure out. So don't worry about creating bugs, and hopefully at this point you're creating friendly bugs like this little caterpillar right now. And as you skill up and become even more advanced, you're going to be creating bigger and more scary bugs. So at some point in the future, when you're creating bugs like these, then you really know that you've become a professional. You will wish to come back to today when you can tackle bugs like these instead. So don't
I
worry
believe
about
it.
creating them. It doesn't mean that you're a bad programmer. In fact, it's an important part of every programmer's journey. Just as a sort of personal note, there was a point in time where I really thought that I was not a programmer of code, that I was just a programmer of bugs. It seemed like every line of code I wrote was a bug. So these are my 10 top tips for debugging. And I hope that anytime when your code is not doing what you expected to do, to come back to this lesson, review these 10 steps, go through them one by one, and I bet 99% of the time, once you've gone through all of these stages, you will have solved your bug and you will have made your code a lot better. And remember that every bug that you catch in your code and that you fix is like lifting a dumbbell in the gym. It's just one rep. And the more reps you do, the better you'll get at programming. In the next lesson, I've got some coding challenges for you to debug. Are you ready to flex your programming muscles? I hope so. Head over to the next lesson and get started.
Okay, I was about to say, because this browser-based environment is not fun. Alright, well, it already shows that. Yeah, I because of PyCharm and their squigglies, I didn't even need to use the debugger for that, so I remember writing this, but us. Guess we need to call it is leap 1994. Let's go with that. No, no, there we go. Okay. Uh, here is not cleanly divisible by 4. How about we know this should be a leap here, right? Pretty sure. Alright, so step over. It is not cleanly. Could have sworn this is supposed to be 400. Yeah. And every year that is divisible by 4. Yes, except, I think, it's not even checking the... Alright, so that's, we're checking 4, 100, I guess because it is not. Because this is false. I just wish it would tell me. We'll try 2008. Alright, let's try 1800. That should go into the next if. Except that is, I think, yeah, okay, yeah, we need not equals. $18.04, true. Wait, no, that was not the right. It's not going to do anything. Maybe I got it backwards. I think I did. It's this, right? Wait, let's get the rules here. On every year that is divisible by 4 with no remainder. So this should be true. If this is true, except every year that is evenly divisible. I always hated this one. Alright, so if this is not met, then it's returned false. If this, except every year, so if this is true, so the year has to be cleanly divisible by 4, but if that year is cleanly divisible by 4 and it is evenly divisible by 100, that is, if these are both true, gosh, I know I've already done this before, but sheesh, unless the year is also, if these are all true, then return true. Um, okay. All right. All right. Don't copy paste to replace the code entirely with a pre. Oh, yeah, no, of course not. Code needs to print. Yeah, we know how this works. If it's divisible by 3, well, I already know this needs to be an and. Okay. Um, Well, you silly goose, these need to be elifs. Oh, now, still not. Okay, take this over here to this machine and remove that. So what are we getting? Nothing. Well, that's because we're not even calling it. Is buzz 100. Okay,
Well done for
all good.
completing day 13. Now, you might still be thinking, hey, Angela, I've completed 13 days and I still don't feel all that confident about writing code in Python. What's going on here? Am I just not meant to be a programmer? What I would have to say to you is, confidence is earned. Like, you can only go so far pretending to be confident, but once you've gone over a number of hurdles, once you've solved problems that you've never solved before, then you start build up those skills. And then the next time you encounter something hard, you'll think back and you'll think, well, this is not as hard as that other thing I did before. So as you keep jumping over hurdles, as you keep solving difficult things, as you keep struggling and overcoming it, you're going to build confidence in your programming. So again, just keep going. You got this.
Well,
Hey
that
guys.
was. I thought yesterday was a nice, refreshing break, but today was nice and easy. I'm not gonna complain. Um, I mean, I definitely need to get much more familiar with the debugger. Uh, so, I guess from here on out we'll be putting putting that to the test whenever I can. So, um, but that's it for day 13. Looks like tomorrow we've got just a project putting together the scope and debugging skills we've learned from the past 2 days and doing a higher or lower game, which is what we did, what was it, yesterday? But I don't know, we'll probably make it fancier. But that's that, and I will see you tomorrow.